In the first part of this video on the Java Collection Framework, we will begin with an overview of the classes and interfaces it contains, and then discuss methods common to most of its classes. In this part, we will provide one example that makes use of the linked list class and another that illustrates the use of iterators. We begin with a discussion of collection classes. A collection class is a class that contains a collection of data elements. They are sometimes also referred to as container classes and implement what are generally referred to as data structures. Next, let's consider the various kinds of data structures that are implemented with these classes. The first are lists that are linear collections that have a first element, a second element, and so on. There are two implementations of lists. The first is the ArrayList class that is implemented using an array. Unlike using an array itself, when an ArrayList is instantiated, the size does not need to be specified. Furthermore, the list has no maximum size. The second is the linked list class that is implemented using a doubly linked list. Unlike an array, a linked list is not a contiguous block of memory, but rather a collection of nodes that are linked together in a way that defines their order. Next are stacks and queues. Stacks are first in, last out structures. There are two kinds of queues. They are first in, first out queues and priority queues. Finally, there are sets and maps. Sets are unordered collections in which there are no duplicates. They model the mathematical concept of a set. Maps are also referred to as dictionaries or key tables. They consist of key value pairs. They are a map in the mathematical sense that they map keys to their corresponding values. Next, we examine a UML diagram that describes the relationships of the interfaces and classes in the Java Collection Framework. For simplicity, we have omitted some of the intermediate interfaces and abstract classes. At the top of the inheritance hierarchy is the interface collection. There are a number of operations that all classes that ultimately implement the collection interface implement. Among the most important operations are the abilities to add and remove elements and the ability to iterate across the entire collection. Below the collection interface are three other interfaces. The one at the center of this diagram is the list interface. As previously mentioned, a list is a linear collection with the ArrayList and linked list classes as two of its implementations. Notice that there is a third class that implements the list interface. It is the vector class. This class and its subclass stack predate the introduction of the Java Collection Framework and were in Java since the first version. Vector and ArrayList both implement a list with an array. They differ in that the methods in Vector are synchronized, which is only a consideration in programs that involve multiple threads. The rightmost of the three interfaces is the queue interface. Two of its implementations are shown in this UML diagram. The linked list class is one of them, so it implements both the list and the queue interfaces. The linked list implementation is what one would use for a first in, first out queue. As the name suggests, the priority queue class would be used when a priority queue is needed. The leftmost interface is the set interface. It has three implementations that we will discuss in one of the later parts of this video. This program makes use of the linked list class. It reads in a list of integers from a file and appends each one to both the front and back of the list to create a palindrome, which it then displays. Here is the declaration of the linked list that will be used. It reads in an integer from the file of integers and then appends it to the front and back of the list. Appending to the front of a linked list is more efficient than appending to the front of an array list, which is why using a linked list is the preferable choice. Scrolling down to the end of the main method, we see that once all the integers have been processed, the list is displayed. Notice that we are using a for each style loop here, which we have only used previously with arrays. That kind of for loop can be used for any class that has an iterator, which is true of all classes that implement the collection interface. We will discuss iterators in more detail shortly. Next, let's run this program. Let's open the input file to compare the input with the output. We see that the output is a palindrome that was formed as described. Before we leave this example, let's make one change. Let's modify the reference type of the linked list to be list rather than linked list. Notice that making that change causes some compilation errors because the methods add first and add last are specific to the linked list class and are not defined in the list interface. Whenever we use methods specific to a particular class, the reference type must match the actual object type. Next, we consider another important feature, which is iterators. Iterators are used to traverse all the elements of a collection. Every class that implements the collection interface has an iterator method that returns an iterator object. The iterator interface provides hasNext and next methods that can be used to perform the iteration. The hasNext method is used to determine when the end of the collection has been reached, and the next method is used at each step to determine the next element of the collection. We have already seen that the for each statement can be used with arrays. It can also be used with any type that has an iterator. Using the for each statement simplifies the code compared to the explicit use of the methods in the iterator class. This program illustrates the use of an iterator both explicitly and by using a for each statement. Notice that the type of the array list is collection. Declaring it in that way is possible because all subclasses of collection have iterators. First, we have a loop that reads in values from an input file. After each integer is read in, it is added to the collection using the add method. Note that the add method is one of the methods defined in the collection interface. Scrolling down to the remainder of the main method, first we make use of the iterator class explicitly. The first step needed is to create an iterator object by calling the iterator method. Then we use a while loop using the hasNext method to determine when the end of the iterator is reached. Inside the loop, we call the next method to extract the next element of the collection. This for each loop accomplishes exactly the same task as the preceding code. Notice that using this approach, no explicit declaration of an iterator is required, nor are the explicit calls to hasNext and next. So next, let's run this program. Now let's open the input file to see that all of the elements were output. Let's try changing list to be a different kind of collection, a tree set, and run the program to see whether the integers are output in the same order. Notice that the values are now in sorted order, and duplicates have been eliminated. Once we study the treeless class, it will be clear why that is the case.